All right, guys, welcome. Today we're gonna learn about binary search. We're gonna try to solve this question. Okay, so let's see. We are given a target array of distinct integers. Distinct means that every single integer is gonna be different. So if we have like an array with, let's just say 1, 2, this is not distinct. Okay, this is two of the same. Okay, so every single integer is distinct and it's sorted in ascending order. So, okay, so that means, okay, let me give a use case. So that'd be 2, 4, 8. See how it's ascending? The number always increases when we read from left to right. Okay, so we could assume that. And the integer, and we're given an integer named target. Okay, let's go check that out. Let's see. Okay, so we're given integer target. What's our goal? Implement a function to search for targets within nums. If it exists, return its index, otherwise return nothing. Okay, so we gotta see. Okay, so find if the target number is inside of nums. If it is, we return the index. Otherwise, we should return -1. Okay. Okay, so solution runs in O of log n time. I know looking through an index for a target, that would probably be O of n, right? Because we have to scan through the whole entire array. Whenever we're given something that's O of log n, you should always come to your mind and assume that, oh, this is a binary search, right? So let's go implement a binary search. Okay, so this is the input. So we're saying nums equal to this, target is 4. Because target is 4, the output is 3. So 0, 1, 2, 3. Yep, that adds up. And because it's already sorted in ascending order or just sorted in any order, we could also infer that this is a binary search question. I haven't coded binary search in a while, so let's go ahead and do it. I know we should have pointers, okay? I would say left pointer would equal to 0. Right pointer would equal to the length of target. Okay, and now we just have, no, the length of nums. Target is the number we're given to see if it's inside nums. Okay, so see 1, 2, 3, 4, 5, 6, 6. Okay, we could subtract 1 just because it's a 0 pointer. So it's not out of index. And now we could do while left pointer is less than or then okay, so if the pointers are both the same, yeah. I think there's two different types of binary search. We could do in place and I think out of place. Left pointer, let's just say equal. Okay, right pointer. Then we could do middle is equal to left pointer. Left pointer plus right pointer. We could do some floor division here because we want just make sure that these are added first before we divide, right? So we have to do order of operations. Okay. So we get that and we divide it by 2. For example, if the number was like 7, for example, it was 7 divided by 2. This would actually output um 3, right? Okay. So we have that. And let's see if nums middle is equal to target, and we could just return middle because that's the index. And if it's not, if middle nums dot middle is bigger than target, if the number that we're currently at is bigger than target, what should we do? We should make the number smaller, right? So it can't equal to target. How do we make the number smaller? We could move the right pointer, right? Because the right pointer is pointed at the biggest element right now. We could move it to the left, but specifically, we're in the left. Because we already searched this partition right here, we know that everything to the right of this is too big, right? So what should we do? We should set right. So let's see, right pointer is equals or equal to middle, right? Okay. Okay, and we could do the opposite. Or we could just say else if. Else if. Elif is the shortcut. So right pointer is equal to middle, but we already seen middle, so we could just do middle minus one. Yes, there you go. And else if nums of middle is less than target, then we could just do left pointer. It's the same thing, except now if the number is too small, we should try to increase the number. How can we increase the middle number? We could do it by actually adding, we could set the left pointer to middle. So let's do that. Left pointer is equal to middle, right? Because we already checked the middle, we just want to add one. Already have that. Okay. Now, we could run this many times, and let's say the number was never there, right? So, for example, we could look at this. Target is 3. So we have this, right? We compute the middle. Let's say the middle was 2. 2 is not equal to 3 because the target 2 is too small, right? So we could move the right pointer or the left pointer to 2, add 1. So now we have 4 in this. So we search 6. 6 is too big, and now we're both at 4. So, so since we're at 4 and we know we scan both parts and they're equal to each other, we just say that the left pointer. Oh, actually, we could just say if that was never found, then return -1. All right, was it -1? Yeah. Okay, I think this should work. Let's go ahead and look at. Yep, and it ran. Okay, we solved it. Perfect. Let's go look at all the other solutions that they had. Um, Damn, this thing is in the way. Okay. So we had recursive binary search. And okay, that's log in. Iterative. Yeah, what we did is actually the iterative spaces that are we could use upper bound. There's a lot of different types of binary searches, I guess. But yeah, we went ahead and solved the problem. All right, thank you guys for watching. See you guys in the next video.